Everyone, my name is Mohammad Airiel bin Michael, and today I will be presenting my mathematical reasoning individual project report. For this presentation, I will be showing an alternative solution to our group project problem, and the method I'm using is the unitary method. Alright, so let's get started. Before we dive into the detail, here a quick overview of what I will be talking about today. I will start with a short introduction, then move to the problem statement. After that, I will explain why I choose the unitary method and go through each step of Polya problem solving process. We will also look at the visual representation, analyze and result, and wrap everything up with a conclusion. Okay, let's begin with a bit of background first. Mathematical reasoning. Mathematical reasoning is basically the ability to use logic when solving problem. It's not just about plug in number. It's about why and how we get to the answer. It's help us justify our thinking, communicate our idea clearly, and apply mathematics to real life situation. So in this project, I'm presenting a different way to solve the same problem that my group worked on earlier. Instead of using the ratio and proportion method, I will be using the unitary method, which I personally find simple and easier to explain. Alright, now that you know what this is about, let's move on the problem itself. So here the situation. A school received 480 gift pack to distribute fairly among three classes: Class A, Class B, and Class C. Class A has 24 students, Class B has 30, and Class C has 36 students. The goal is simple. Make sure each student receives an equal share according to the class size. Pretty fair, right? But now how do we make sure the distribution is really fair? That's where the unitary method comes in. Okay, next. I choose the unitary method because it's very straightforward. You start by finding the value for one unit, or in this case, one student, and then you scale it up. It's step by step, logical, and super easy to verify. This approach also makes it clear to see how fairness works, because you're not comparing ration directly, you recalculate from the smallest unit to the total. Okay, now let's look at how I applied this method, starting with the first step in Polya model. So, step 1. So, the first step is understanding the problem. We need to divide 480 gift pack among three class fairly, right? That means every student should get the same number of gift pack. When we add all the students together, 24 plus 30 plus 26, we get the total of 90 students. And that's what we will use as the basis for the whole calculation. Now for the second step, devise a plan. The plan is simple. First, find how many gift pack one student should get. Then multiply the number by the number of students in each class. And finally, check that the total add up to 480. By starting with one student, we make sure the whole distribution is built on fairness. Okay, let's see how this plan works in action. Okay, step 3. Carry out the plan. Alright, this time to do the math. We start by dividing 480 by 90, and we get 5.33 give back per student. That means in theory, every student get around 5.33 give back each. So when we multiply it, class A 24 student times 5.33 give 128 packs. Class B 30 student times 5.33 we got 160 pack, and class C 36 student times 5.33 give 192 packs. If we add them all together, 184 plus 160 and 192, we got 48 perfect. Everything add up directly. So to make this clear, here the bar graph showing how the gift back are distributed. As you can see, class C has the tallest bar since it has the most students, followed by class B and then class A. This shows that largest classes get more pack, but remember, every student still get the same share. That's the key idea behind proportional fairness. Next, step 4, look back. This step is all about reflection and checking. So when I add up all the gift back again, 128, 160 and 192, the total is still 480. That confirms my calculation is accurate. What I like about the unitary method is how easy it's to verify. Since it starts from one student share, the logic follows nicely. It's simple to track and simple to prove. Now let's analyze and interpretation. The unitary method really highlights step-by-step reasoning. It's logical and consistent. It shows fairness by making sure every student gets exactly the same portion. Each student gets 5.33 gift back, and that's true across all class. The bar graph also helped me visualize the relationship. The biggest the class, the more total pack it receives. This shows how mathematics isn't just about calculation, but also about logical explanation and justification. It's reasoning in action. Now, to wrap everything up, using the unitary method as an alternative solution proves that we can approach the same problem in different logical way. This method follows Polya 4 steps: understand, plan, execute, and reflect. It's helped me see that reasoning is not just about getting the right number, but understanding why it's right. As a future educator, I think that's really important, because when students understand the reason, they don't just learn maths, they learn how to think it critically. So yeah, that's my presentation. Thank you so much for listening. Once again, thank you everyone for your time. I hope you enjoyed this presentation as much as I enjoyed prepared. Have a great day. Thank you.